What's going on, ladies and gentlemen? We're going to talk some more about similarity with triangles today. So we're going to do what we call overlapping triangles. Right here you can see a picture, a little bit of an example of overlapping triangles. So here's a theorem that we need to know and be able to use. A theorem says that if a line is parallel to one side of a triangle, so right here, for example, if BE is parallel to CD, and it intersects the other two sides, as we can see right here and here, then the triangle formed, this smaller triangle that we form, is similar to the original larger triangle. So anytime we draw a line through here that's parallel to this line, it's going to make a small triangle similar to the big triangle. So let's see why this is true. So if BE is parallel to CD, then the corresponding angles which are congruent are, well, first off, this angle is the same angle for the little triangle and the big triangle. So it's obviously going to be congruent to itself for the little triangle and the big triangle. But then also, because these lines are parallel, they're being cut by a transversal, so we can say this angle and this angle are going to be the same because they're corresponding angles. You could also say E and D would be the same. So right here we say angle A is going to be congruent to angle A, and then angle B is going to be congruent to angle C. That could also be D and E. So because of this, by angle, we know that triangle ACD is similar to triangle ABE. Alright, so hopefully we understand how overlapping triangles works and why the two triangles are similar. So let's keep on cruising. Let's do a couple examples. So let's look at the properties, or the proportions for the given diagram right here. So we got this overlapping triangle, and we want to figure out, well, what completes this proportion. So MI is over ML. So MI, we can see right here, corresponds to ML. So a lot of times you can think of this as the part of the side over the whole side. Okay, that's many times the easiest way to think about this. The part of the side over the whole side. So MI is this part over the whole ML. So if we look at MT, MT is this part over the whole, which is ME. So in B, now we got MI over ML, so that's part over whole, and then we got EL on the bottom. Now EL is this side. So if that's the whole, then what's the part? Well, the part would be the side that's parallel to it, IT, or sorry, TI. Not the wrapper, the side, TI. Why would we not want to say IT? Well, if we used EL, EL would correspond to TI. IT would be backwards. Alright, so then this one, we've got MT over ME, so that's the part over the whole. So then what would be over LE? Well, the part that corresponds to LE is IT. So this time we would put IT. Alright. Okay, so now we can use these properties to solve for variables when we don't know a side length. So let's practice doing that a little bit. So for this triangle right here, we've got this side is 10, the small part right here is 6, this length AE is 8, and the whole thing is x. So we can set this up, set up a proportion to solve for x. So what's the part of this side that we know? We know 10 over the whole. What's the whole side? Well, if this is 10 and this is 6, add those together, the whole side is 16. What's the part on this side? 8. And the whole is x. That's what that brace means. It goes from end to end. So that's x. So now we cross multiply. 10 times x is 10x. And we do 16 times 8. 16 times 8 is 128. And divide by 10. And divide by 10. So x is going to be 12.8. Okay, this length from here to here is 12.8. Alright. So let's do another one, number 2 right here. So what is the part of this side that we know? We know 4 over the whole, which is 7, equals, what is the part between these two lines? 2, okay, because it's on the smaller triangle, over the whole x. Okay, now it might be easier for you to see this if you split it up into the two small triangles. So we can say, okay, this is going to be 2, this is 4, and then draw the bigger triangle and say, all right, this is 3 plus 4, which is 7, and then this is x. So then it might be easier for you to set up your proportion and say, okay, well, we'll do 4 over 7 equals 2 over x. Maybe you need to split it up. That's fine if you want to split it up in order to set the proportion and just draw two separate triangles. Okay, so we do 4 times x and get 4x, and 2 times 7 is 14. Then we divide by 4. So 14 divided by 4 is going to reduce down to 7 over 2. And when we do 7 over 2, we get 3.5. Alright, so x must be 3.5. Cool. Alright, let's keep on cruising. So sometimes whenever you have overlapping triangles, there's something that can be a little bit easier to use called the side splitter theorem. Okay, so basically what this says is that if a line is parallel, just like we've been talking about, if it's parallel to one side and intersects the other two sides, then it separates the sides into segments that are proportional. So basically right here you see AB over BC. This is AB over BC is going to be equal to AE over ED. So you don't have to worry about the whole. You can just set the two segments as fractions, and they should be proportional if this is parallel to CD. Alright, so sometimes this could be a little bit easier to use. So let's practice that a little bit. Alright, so number 1 right here, we're going to do the same thing, but now we're not going to worry about the whole. Since we're given these two sides, we're just going to set a proportion with these two sides right here. Now, this is important. You cannot use this with the two lines that are parallel. You can only use it with the sides that the parallel lines intersect. Okay, so you can't use it if you're given the parallel lines. All right, so what we can do on this one is we can say, all right, well, x over 10 should equal 5 over 8. There's a lot of ways to set up the proportions, but that's one way right there. X over 10 equals 5 over 8. Cross multiply, that's 8x. And 5 over 10 is 50. And then we're going to divide 50 by 8. And whenever you divide 50 by 8, you should get 6.25. So that's the distance right here, 6.25. I'm going to go ahead and do number 2 and let you guys try number 3 and 4. So same thing right here. We're going to say x plus 5 over 8. You could do 8 over x plus 5. Either way is fine. But you got to make sure you put the side that matches in the same location. Since I put x plus 5 on top, I got to put x on top of this one over 6. So now you cross multiply. 8 times x is 8x. Now be careful here. You do 6 times this. You got to do 6 times the x to get 6x, and 6 times 5 to get 30. Now I'll minus 6x minus 6x. So I get 30 equals 8x minus 6x is 2x. And then we divide by 2. 30 divided by 2 is 15. So now I know this side is 15. But what's this side? Well, it's whatever x is, just 15, plus 5. So this side is really 15 plus 5, so it's really 20, not 15. Or sorry, no, yeah, not 15, because you got to add 5 to x to get that side. All right, I'm going to go ahead and pause it and let you all try number 3 and number 4. Go ahead and pause your video, give them a try. All right, so these are a little bit tougher, but I think you can handle it. So what you're going to do, again, if you're trying to find an unknown piece on one of the sides right here, you can just set up a proportion with the 4 pieces that make up those two sides. So we can say 4 over 2 equals 7 over x. That's what I did right here. And you cross multiply and divide and get 3.5 for x. But on this part, when you're trying to find one of the two parallel lines, you have to do the part over the whole, the way we did it on the first couple examples. So you can't just say 7 over x equals 6 over y, or sorry, 4 over 2 equals 6 over y, because those aren't proportional. So you've got to do the part over the whole, and then this is your part, and this is your whole. So we've got to say 4 over 4 plus 2, which is 6, so we get, that's where we get 4 over 6 equals the part 6 over y. Alright, so that's what we got to do when we're finding one of the parallel sides. You can't do the just the part over the part and part over part. You got to do part over the whole. So now when we cross multiply, we get 36 equals 4y divided by 4, so y must be 9. So this side right here is 9. Now this one was a little bit tougher, had some extra terms in it, but you still do it the same way. Okay, so first the easy part. If we just want to find this side right here, you have to take the part and put it over the whole. So we do 14 over the whole side, 14 over 14 plus 6, which is 20. And then put that over, or set that equal to the part, which is y, over 40. So that's where we set up that to find y. Cross multiply and divide, and you get y equals 28. So this piece right here must be 28. Now when we're finding x, okay, this is one of the sides of the triangle, and here's the other side. So we can just do a proportion with a piece over the piece and a piece over the piece, or part over part. We don't have to do the whole. So we can say 2x plus 7 over x plus 2 equals 14 over 6. Cross multiply, again, you're multiplying two terms, so you got to do the 6 times 2x to get 12x, 6 times 7 to get 42. Same thing over here, 14 times both of these to get this part, 14x plus 28. And then you just solve from there, subtract your 28, that leaves 14. Subtract 12x from the left side, that leaves 2x. 2x equals 14, so divide by 2, x must be 7. Okay, so now we know x is 7, but if we actually want to find the side lengths, then we've got to take x and plug it back in. So if x is 7, then GH must be 7 plus 2, which is 9. And then FG must be 2 times 7 plus 7. 2 times 7 is 14, plus 7 more is 21. So that's how we could find the lengths of those sides right there. Alright, so let's keep on cruising. We're just about done. Okay, so the side splitter theorem we just talked about. One cool thing is if a line is parallel to one side of the triangle and intersects the other two sides, it's going to divide those two sides proportionally. So what that means is we can say AB over BC, so that's AB over BC, is going to equal AE over ED. Okay, but if there's more than two parallel lines, it still works. Okay, so if you have three parallel lines, the same thing still applies. AC over CE is going to equal BD over DF. Okay, it doesn't have to necessarily be a triangle. Just having three parallel lines with two transversals will give you the same situation. So let's look at a couple of examples. So if AB over BC, what's it going to equal? So this is AB over BC. Here's EF. So what's going to be on the top? Of course, DE. If we do AB over AC, AB over the whole AC, then DE is going to be over the whole over here, which is DF. And then if we've got DF over EF, that's the whole over this part. Then over here we've got to have the whole AC over this part, which is BC. Alright, so just some ways to understand the proportions whenever you have three parallel lines. Let's practice a couple of those real quick. I'm going to do number 2 and 3 and let you guys try 4 and 5. So right here, we've got three parallel lines being cut by two transversals. So we've got the situation where this segment over 14 should equal 3 over x. Cross multiply, 2 times x equals 14 times 3, which is 42. Then we divide by 2, so x is 21. So this side must equal 21. Right, number 3, you could do it similarly. Again, these proportions you can set up a lot of different ways. I can say 4 over 10 equals x over 6. You could also say 4 over x equals 10 over 6. You could do x over 4 equals 6 over 10. A lot of different ways to set them up. 4 times 6 is 24, and then 10 times x is 10x. Divide by 10, so x must be 2.4. Alright, so I'm going to go ahead and pause it and let you guys try number 4 and number 5. Pause your video. Right here, when we set this one up, you got to be careful because 24 is the whole. So since it's the whole, you have to make sure that you use the part over whole right here. So if we do x over 24, that's this part over the whole, so we got to do this part 5 over the whole, which is 5 plus 10, 15. So then once you cross multiply, you get 15x equals 120, and you divide by 15, so x must equal 8. Now on the last one, you can set it up with x minus 4 over x minus 1, part over the part, equals 8 over 12, part over the part, cross multiply, 12x minus 48 equals 8x minus 8, because again, you got to multiply the 8 by both of these and the 12 by both of these. And then you subtract 8x, which leaves 4x, add your 48 to the other side, which gives you 40, 4x equals 40, divide by 4, so x equals 10. But again, that just tells us x. If you want to know the actual segment lengths, you have to plug x back in, because this segment is whatever x is, but 4 less, right? We take away 4. So you take away 4 from 10, that leaves 6. Right here, take away 1 from 10, that leaves 9. So that'll tell us those two side lengths. All right, appreciate your all's attention. Time to practice.